Hello and welcome. This is a Edexcel D1 topic video. In this video we're going to be looking at the last few types, so to speak, of algorithms. Well, really, it's not the last type of well, I don't know. So basically what it is we're going to be looking at binary search algorithm, which I'll explain is very, very closely linked to the quicksort algorithm, okay, except essentially the main difference is that we'll be using letters and names rather than numbers, but the theory is exactly the same. Also, we're going to be looking at something called something called bin packing algorithm. Now, it literally is packing a bin, okay, but obviously there's a bit more to it than that. Okay, there's just a few methods of working it out. I mean, you could just logically add them all up, and that is one of the ways, okay? So that's really all I want to cover in this video. As I said, in the next video, we're going to be looking at Prim's and Kushgal's algorithm, and we're going to therefore also, in the next video, we're going to be looking at Prim's algorithm in a table. But as I said, that's for the next video. Okay, so the first thing I was going to talk about is binary search algorithm. Now, in the quick sort algorithm, okay, you would rearrange you would sort the numbers out, they'd be in order, okay, and I don't know, be something like this: 1, 2, 7, 9, 10, 24, 25, 26, 28, 30, and you'd go, use the quick sort to find the number 7, okay, and obviously therefore you would go halfway, work out, well, everything bigger, this must be all bigger than 7, so you cross that out, and then you focus on that bit and sort of cancel down and cancel down. Okay, so hopefully that made a bit of sense. Now, using that idea of sort of cancelling down, now it's very close to the method for this is also used just out of interest in FP1's numerical solution video, in which we used, oh, I forgot the name of it, that's quite embarrassing actually. One of the it's not linear evolution, I can't remember the name of it, but there is a numerical solution. I'll probably put it on above my head in this video or in the description, okay, which is very similar to this method in terms of we half it, and then the range we know it's not in, we cross that out, and then within the range that we know it is in, you half that, and then everything on the left hand side. So you keep cancelling down until you find that single point, okay? So obviously you would do a new line now of just this, and then you would half that as we've done here, and a new line, and a new line. But as I said, in this algorithm, they generally use letters or names, okay? So let me just, I mean, obviously I could come up with a few names, but I'm that intelligent. Sorry to boast, but I just want to let people know I can do these type of things. But obviously, just so basically, sorry, to find the middle, what we did was the number of terms plus 1 over 2. And then if it needed rounding up, we would round it up. Otherwise, we would just choose. If it was a whole number, we would just choose that. Okay. So I'm just. Okay. Yeah, this is quite a long one. So I'm just gonna write a list of names. Okay. Hopefully. Right, yeah, I'm going to pause the video, write a list of names. I'm going to use a binary search algorithm. Okay, so I've got a list of names on the board there. Specifically, we've got 10 names, okay? And the first name that I asked to find is Robinson. Now, you're more intelligent people, we can just go, there's Robinson, there we go. But you've not actually used an algorithm, but that's obviously the thing that testing you on. Okay, so we've got 10 names, and we want to find the middle. Now, you can cancel down and cancel down and cancel down, but the way to do it in this is use the formula n plus 1 over 2, okay, which comes to 5.5 because it's 10 names. So you choose the sixth name as the sort of pivot, if you relate it to the previous one. Okay, so well, what you would do then. So this is a six name. All right. Where is it? It's a 6 name. Okay, and you know everything on the left hand side because it's in alphabetical order. Obviously, Robinson's great and all that. So you cross all that out because you know it's not going to be in there. So we're now focusing on and because it's not this, the middle one, you can cross that one out as well. So we know it's going to be in this range somewhere, and obviously quite clearly it is. So what you would do then is you would half that again. Okay. So what you've got here is it's the 4. Okay. So you do z plus 1 over 2. So it's the third one, and then is it going to be on the left the best? Well, yes it is. So you cross all the ones on the right, and then you do the same again, so you get the middle as between the Lung and Robinson. Okay, well it's not going to be Lung, so it's Robinson. Okay, and that would be your binary algorithm. Now all them steps that I listed there, the first step was sort of halving this, okay, and taking off the left. Then you would write a new line with just Lung and Robinson, Saludo and Scadding. Okay, nice, good names. Okay, so that would be your second step, writing it out. Okay, and then your third step would be halving the entire. And your third step obviously. Your second step would have been included in crossing out Lung. Okay, and your third step would have been halving this range. Okay, so that would be your third step, and then your fourth step and final step would be halving Lung and Robinson. Okay, and obviously therefore you quite clearly find Robinson. Now each one of them steps you would obviously write as a new line. I've just been lazy, and I've just kept it all as one line because why the hell not? Okay, so anyway, that's really what the binary search algorithm is. I don't think I need to do too much more on that because really it's just a case of halving the range and crossing out the range you know it's not in because it's in alphabetical order. Okay, and then just focusing on halving the range that you know where the name or letter that you're trying to find lies. Okay, but it does require you being able to understand the alphabet, which is a bit of a pain. I mean, I don't know whether we're going to do that, but hope if we got. Anyway, besides dwelling on our future in the despair that humanity is going to face, we need to get on with the next algorithm. Okay, so that's a binary search, so that's fairly easy. And now this bin packing algorithm is fairly simple, but there's just a little bit of more complexity to it. Okay, as I said, it's not that much more complex really, which says quite a lot to be honest, because that, as I think you'll agree, was very, very simple indeed. Okay, so I was saying what this bin packing algorithm actually means. Well, yes, it has actually something to do with a bin, but unlike the binary search where there's only one method to it, and it's just learn that method and you can apply it to any question which requires you to use a binary search. There's a couple of methods for bin packing, and I'm just going to list them now. Okay, so your first method is something called well, actually, just want to give the proper name of it. Sorry, I do apologise. Called full bin packing, and essentially, I mean, I could just talk you through that now. Full bin packing, it only refers to, it's literally as simple as just picking the fewest number of numbers that allow you to add up to the height of the bin. Because obviously we're packing it full of boxes, so obviously you've got a height of a bin. I don't think I really need to say this, say it's 2 meters, and you need to know how many boxes of varying heights that you need to fill the bin. Okay, and it's not really an algorithm, that first one, so that's kind of why I was hesitant to put it on, but in the end it's just another thing to add onto the list. Okay, the next one is a little bit more complex. It's called first fit algorithm. Now really you could put that as increasing first fit algorithm, which kind of gives you a clue to the second, as to the third, sorry, which is decreasing first fit algorithm. Essentially, obviously, these two are closely related, and we'll go on to explain how. But you probably already guessed, to be honest. Intelligent people. Okay, so that's the three sort of main ones that so just should be off the top of your head, yeah, when you're looking at this, because as I said, they are fairly straightforward. Let me just check. The fourth one is called. No, it's not a fourth one. No, I might have missed it out, but who really cares? Okay, so they're the as I said, the algorithms that you would use for bin packing. Now, as I said, full bin packing is very, very simple. Now this first fit algorithm. Okay, so I need to probably come up with some box heights and boxes and stuff. So instead of me trying to do that and completely and utterly failing, I'm just going to use a couple of heights and stuff out of here. Although that might be a mistake, so I reckon this is going to take me about 5 minutes just trying to figure out what the hell this all means, because generally the books aren't that good. Oh, actually this found it straight away. Okay, so we've got a couple of boxes here. Called box A, has a height of 0.3 metres. Now we're assuming the dimensions volume is sort of constant, okay, with the height. What I mean by that is we don't have to worry about the width of the box, each are the same. And B has a height of 0.7 metres. C has a height of 0.8 metres. D also has a height of 0.8 metres. E has a height of 1 metre. F has a height of 1.1 metres. G has also a height of 1.1 metres. H has a height of 1.2 metres. And is there another one? Yeah, I'm just trying to, it's a little bit hid away there. I has a height of 1.5 metres. Okay. Yeah. So, we're told that the height of this bin is 2 metres. So, ideally, what we've got to add up is the 2. Now, the first one, you could quite clearly pick, say, A, B, and E. Okay? And that quite clearly gets you to 2 metres. Or, you could pick D and H. Obviously, you're intelligent people. Just any boxes that would add up to 2 metres. Okay? Alright. So, what does this first fit algorithm mean? Well, the way I think of it, it's a bit like 21. I don't know if you've ever played 21, or 20. I think it's 21 or Bust it's called. I'm getting into gambling already. Well, it is maths and there's probability of gambling. Ooh, the douche. Anyway, tried to be a bit humorous there, but didn't work. Okay, so if you've ever played 21, the gist of it is, if you haven't played 21, the gist of it is you have, obviously there's a dealer, a set of cards with the pack of cards, okay, and obviously you get two cards, and you're very lucky if them cards add up to 21 in terms of you get an ace and a king, okay, so obviously a king's worth 10 and an ace can be worth 1 or 11, okay, so you could say that was 21. Or if you didn't get them cards, okay, you would keep asking the banker for another card, okay, and you would keep getting another card and adding that on to your current score, okay, and if you got 21 or higher, say if you were on 18 and you got a 7, okay, but it's going to take you over 21, so then you're out, okay. Very, very similar situation to this, okay, in terms of obviously we're not dealing with cards and bankers, but we're dealing with heights of boxes. Now the reason I say that is because you get 2 and you keep adding it on. Well, you don't really start with 2, you just add it on as you go along, and until you get a height of 2, or if you go over 2, so it's the same principle as 21. Okay, so hopefully when I go through this example you'll see what I mean. Alright, so what we do is obviously you would start with 0.3, so you could write like cumulative frequency underneath, okay? So you'd start with 0.3, and then you'd add on 0.7, like quite clearly get you to 1. You'd add on 0.8, like you get you to 1.8, and then you go, oh, I only need 0.2, but the only box you've got next is 0.8, which will obviously take you above 2, okay? Well, 2.6 specifically, but you know, I don't really need to help you get that. Anyway, that's the idea of this, okay? But what would you do then, okay? Because quite clearly there's no point starting again, you're going to get the same answer. Well, you start exactly from where you left off, okay? So, great, put the book down. Sorry, I do apologise. Obviously, I know I'm doing. Okay, so now, sorry, I was just double checking something. Alright, so now we've crossed out at 0.8, we start from 0.8, okay? So you do 0.8, and then you add 1, so obviously gets you 1.8. And then obviously when you add 1.1, that takes you over 2, so you cross that out, okay? And then you start from 1.1 again. So you do 1.1, and then you add 1.1, well, it takes you over 2, okay? You start from 1.1, start from G, 1.1, add H, well obviously gets you over 2, and then you start from H, 1.2, and when you add 1.5 it takes you over 2. So quite clearly, this first fit algorithm doesn't always work. Okay? So obviously in your given question in the exam it will work, but I've just obviously picked a set of numbers from the book that actually don't work. Which is great, so I've wasted my time there. But you get the idea, okay? And if it were to work, which it will obviously will do in the exam if you've done it right, you will get a set of numbers that will add up to 2, okay? So that's your first fit algorithm. Now quite clearly, your decreasing first fit algorithm is exactly the same method as this, but instead of I being 1.5, I would be 0.3, okay? Basically we reverse the numbers in terms of we do them from biggest to smallest, quite clearly. But the method stays exactly the same. So hopefully you can see the idea of 21 or bust in there, and I tried to give you a bit of a guide to that, but it's going to be pretty pointless if you ever played 21. But anyway, it's a good thing to do after obviously you've done all your revision. Okay, so that's the main idea of this. Alright, so that's the end for this video. Now if you want me to do a few more examples like that, please do let me know. I'm just trying to get through kind of the D1 syllabus before the exam, so as I said, the gist of that was fairly self-explanatory. I mean, obviously that particular example that I did didn't work out so well, but yeah, what are you going to do? No, absolutely nothing. Shoot me? Well, I just want to do that to myself at the moment. Anyway, so apart from death and the despair of humanity and all the sins, hopefully being able to understand this D1 topic. Okay, so thanks for watching. As I said, if you have any questions or queries on what I've done on this video, please do leave a line in the comments below and I'll get back to you as soon as I can, rather than as late as I can, obviously. People say that. It really annoys me when people say that. I say at the end of every single video I do, but still, I wind myself up, so achievement unlocked there. Okay, so thanks for watching. Hopefully we'll see you in the next D1 video, which as said should be about Kruskal and Prim's algorithm, which I'm going to break down into 2 very simple definitions. Okay, so thanks for watching, and we'll see you in the next video.